Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So I am going to use y equal to yc plus yp method to solve the given problem using variation of parameters. So let's get going. Part 3. Solve y double dash plus y equal to 1 by 1 plus sin x or d square plus 1 into y equal to 1 by 1 plus sin x using variation of parameters method. So here we are given a differential equation of order 2. Given differential equation y double dash plus y equal to 1 by 1 plus sin x. Consider this equation as equation number 1. We can write y double dash as d square y by dx square plus y equal to 1 by 1 plus sin x. Now we can write d square y by dx square as capital D square y plus y equal to 1 by 1 plus sin x. Right. Now take y common from the two terms of LHS. We'll get d square plus 1 into y equal to 1 by 1 plus sin x, which is in operator form. Equation 1 in operator form is equation 2. Right? F of d, say f of d into y equal to sum r of x or function of x, where f of d is d square plus 1 and r of x is 1 by 1 plus sin x. Now we'll find the solution to equation 1 or equation 2 using y equal to yc plus yp. We'll find yc using the auxiliary equation and later we'll find yp using yc. So let's begin, or let's see auxiliary equation to find yc. Here the general solution is given by y equal to yc plus yp, right? Now we are going to find yc using the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 1, right? Let's replace differential operator d by m, so that we'll get f of m equal to m square plus 1. We'll just replace d with m. Then the auxiliary equation becomes m square plus 1 equals to 0. From this we'll find roots to this equation. M square equal to minus 1, then m equal to plus or minus square root of minus 1. Since square root of minus 1 is I, so we'll get m equal to plus or minus I. The roots are real and the roots are complex conjugate. Therefore m equal to plus or minus I. The roots are complex conjugate. We know that when two roots are complex conjugate, when the roots are complex conjugate, then yc, that is the complementary function, looks like e power ax of c1 cos bx plus c2 sin bx. Right? In case of a 0, we'll get e power 0 into x, which is e power 0 of c1 cos bx plus c2 sin bx. Right? Since e power 0 is 1, so we'll get 1 into c1 cos bx plus c2 sin bx, which gives us c1 cos bx plus c2 sin bx. Let's now write the complementary function to our problem. Yc equals to, just compare plus or minus I with plus or minus ib. Then for b equal to 1, we'll have c1 cos 1 into x plus c2 sin 1 into x. That is yc equals to c1 cos x plus c2 sin x. Therefore yc equals to c1 cos x plus c2 sin x. Let yp equal to, just replace the constants or parameters with functions of x, a and b, then we'll get yp equal to a cos x plus b sin x. Now we can compare yc with c1u plus c2v or yp with au plus bv to find u and v, where u is cos x and v is sin x, right? Where a and b are functions of x, u equal to cos x and b equal to sin x. We'll find a using formula integral minus v into r of x by u v1 minus v1 into dx, and b is given by u into r of x by u v1 minus v1 into dx. If you notice, we are having u v1 minus v1 in both the formulas, so let's begin with u v1 minus v1 and later we'll find a, b and yp, and finally we'll write the general solution using y equal to yc plus yp. U into v1 is nothing but derivative of v with respect to x, minus v into u1 is nothing but derivative of u with respect to x. This gives us u is cos x of derivative of v with respect to x, that is sin x with respect to x, minus v sin x into derivative of u, that is cos x with respect to x. This gives us cos x into derivative of sin x with respect to x is cos x, minus sin x into derivative of cos x with respect to x is minus sin x. This gives us cos x into cos x is cos square x, minus into minus plus sin square x, or we can write it as sin square x plus cos square x. Since we know that sin square theta plus cos square theta equal to 1, from this we'll get sin square x plus cos square x, which is 1. Therefore, uv1 minus v1 equal to 1. A is given by formula minus v into r of x by u v1 minus v1 into dx. Since r of x is a fraction, so we'll write the formula as minus v by u v1 minus vu1 into r of x for our convenience, okay? Is equals to minus integral v is sin x by u v1 minus v1 is 1 into r of x is 1 by 1 plus sin x into dx, right? This equals to, you can just write minus inside the integral, minus sin x by 1 plus sin x into dx. Now the denominator you are having 1 plus sin x, right? If you change the sign, you'll get 1 minus sin x. Just multiply and divide the fraction with 1 minus sin x. Then we'll get integral minus sin x of 1 minus sin x by 1 plus sin x into 1 minus sin x into dx. This gives us integral minus sin x minus into minus plus sin x into sin x is sin square x by 1 plus sin x into 1 minus sin x into dx. This gives us integral minus sin x plus sin square x by, the denominator is of a plus b into a minus b form, so we can write it as 1 square minus sin square x into dx is equals to minus sin x plus sin square x by 1 minus sin square x dx. Since we know that sin square theta plus cos square theta equal to 1, from this we'll get cos square theta equal to 1 minus sin square theta, right? So let's replace 1 minus sin square x with cos square x, and we'll get a equal to integral minus sin x plus sin square x by cos square x into dx. So in the numerator we are having two terms and in the denominator we are having one term, so we'll split this into two terms. A equal to integral of minus sin x by cos square x plus sin square x by cos square x into dx is equals to integral of, we can write cos square x as cos x into cos x and write sin square x by cos square x as tan square x into dx is equals to integral minus sin x by cos x into 1 by cos x plus tan square x into dx. This gives us integral of minus sin x by cos x is tan x into reciprocal of cos x is secant x plus tan square x dx. Since we are going to apply integration, so we know that integral tan x secant x dx equal to secant x and integral secant square x dx equals to tan x and integral dx equals to x. Here we are having tan square x. We'll write this tan square x in terms of secant square x using the identity 1 plus tan square theta equal to secant square theta. From this we'll get tan square theta equal to secant square theta minus 1. Just replace tan square x with secant square x minus 1, then we'll get integral of minus tan x secant x plus secant square x minus 1 into dx. Now we can split the integration, integral minus tan x dx, tan x secant x dx plus integral secant square x dx minus integral 1 into dx is dx, right? Now apply these formulae, we'll get A equal to minus integral tan x secant x is secant x plus integral secant square x dx is tan x minus dx is x. Therefore A equal to minus secant x plus tan x minus x. Let's now find B. B is given by integral u into r of x by u v1 minus v1 into dx. We can write it as u by, see, r of x is a fraction, so we are writing the integrand as u by u v1 minus v1 into r of x, okay, for our convenience. This is equals to u is cos x by u v1 minus v1, which is 1, into r of x is 1 by 1 plus sin x. This gives us integral cos x by 1 plus sin x into dx. Let f of x equals to 1 plus sin x. Then f dash of x will be derivative of 1 with respect to x is 0 plus derivative of sin x with respect to x is cos x, which is equals to cos x, right? And the integrand is of integrand is of f dash of x by f of x form. So we know that, since we know that integral f dash of x by f of x into dx equal to log mod f of x, right? So we can apply this formula here. Since the integrand is of the form f dash of x by f of x, so we'll get log mod 1 plus sin x or be equal to log of 1 plus sin x, right? Therefore be equal to log of 1 plus sin x. We got a and b. Let's now find yp and later we'll find the general solution to the problem. Yp is given by a cos x plus b sin x. Now substitute a and b here. We'll have minus secant x plus tan x minus x into cos x plus b log of 1 plus sin x into sin x, or we can write it as, just take minus common from all the three terms, we'll get minus of secant x minus tan x plus x into cos x plus log of 1 plus sin x into sin x, which is the required yp. Now we got yp. Let's now write the general solution. Therefore, the general solution is given by y equal to yc plus yp. We have yc and yp, right? Let's substitute them. We have yc c1 cos x plus c2 sin x plus yp is minus of secant x minus tan x plus x into cos x plus log of 1 plus sin x into sin x, which is the required general solution. So this is all for now. I hope you'll understand. We'll see you in the next video. Until then, bye bye.